One of the most important math concepts to teach conceptually is fractions. Fractions can be very difficult for many students, and sometimes students will report that they felt like they did fine in math in elementary grades until they got to fractions, and then they were confused. So we need to make sure that we start at the very beginning and teach this very well. Another reason to teach it so carefully is that if we teach fractions well, decimals and percents, which are obviously very closely related to fractions, will be much easier for students to understand. Starting at the beginning with fractions means really reinforcing some very key ideas. One of those ideas is that fractions are made up of equal parts. We have a whole thing and we're dividing it into parts that are the same size. That equal part needs to be stressed. It's also very important to start out with whole objects and show all of the parts, not just some of the parts. Sometimes in schools we start right away with 3/4, 3 out of 4, or 2/3, 2 out of 3, and students don't understand that there are two parts in one whole if we cut it in half. So 2 halves is 1, 4 fourths is 1, 8 eighths is 1. They can see that all of the pieces added together make the whole, which is why we name the fractions the way we do. 1 part is an eighth if there are 8 parts in the whole. It also helps students understand that as we add more parts, as we divide something into more parts, the parts get smaller, but there are more of them, which means that that bottom number, that denominator, that name, gets bigger as the parts get smaller. And this is very contrary to things that they have learned thus far. So it's important to emphasize that. It's also important to make sure that students are working with fractions as one whole or one group. Often in schools, we work with fraction circles or fraction strips, or we work with parts of a pizza. But what we don't often include is parts of a group, working with things that are actually separate items, like a bag of Skittles or a bag of M&Ms or some other group of stones or counters that can be separated into groups. So for example, in the pictures here, you see one whole circle separated into 3 parts. So if we took one of those parts, we would have 1/3. Here we see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 items separated into equal groups. But if we're talking about the groups, we actually only have 3 groups. 1, 2, 3. So if we're talking about groups and we're talking about this group, we would say we have 1 out of 3 groups. Working with one whole and working with separate items that are grouped shows students that fractions can be represented either way. Another important concept to teach very carefully to students is that we can have one amount of something that shows a part of a whole, but it can have different names depending on how big the pieces are. So for example, if we cut this rectangle into 2 parts and we take one of those parts, we have 1/2. If we take that same rectangle, but we cut it into 4 parts and we take 2 of those 4 parts, we have a piece this size, which is 2/4. But it's the same as the 1/2. It has a different name, and the pieces are smaller, there are 2 of them, but the total size we have is the same. If we take this rectangle and we cut it into 8 parts, and we take 4 of them, we have 4 out of 8 parts, or 4/8. But if we look at the whole piece, we see that we still have the same amount. It's the same as this, and it's the same as this. The only difference is that the pieces are smaller. Understanding that one amount, one part of something, can have different names but not be different is important for students. We also want to make sure when we're working with fractions with students that we include wholes and parts, and not just parts. For example, in this picture, you see that there are 3 whole circles, because they're all filled in red, 3 whole circles, and then there are 1, 2, 3, 4, 5 pieces out of 6 pieces that it would take to make another whole circle. So we have 3 and 5/6 circles. We could also look at the individual pieces and count up all of those. So if we go back to our whole circles, we have 6 pieces in each one. So we have 6, 6 more, 6 more, that's 18, 19, 20, 21, 22, 23. We have 23 pieces that are all called sixths. And they're called that because it takes 6 of them to make one whole. So we have 23 sixths if we count individual pieces, and if we count wholes and parts, we have 3 and 5/6 circles. Very early in fraction instruction, we want students to be able to create and identify equivalent fractions, not to find them with numbers, but to see what they look like. So for example, if we divide this circle in half and we take 1/2 of it, we would see that we have 1 out of 2 pieces, or 1/2. And what we want to ask our students then is, could we take that 1/2 and could we name it something else? What if instead of dividing the whole circle into 2 parts, we divide it into 4 parts? Now, how would we name our 1/2? We would have 2 parts out of 4 that are in the total. We could take this further. We could divide our circle into 6 parts. 1, 2, 3, 4, 5, 6. What does our 1/2 look like now? How many pieces are in it? 3 pieces out of 6. Or we could divide our circle into 8 parts. And if we took our 1/2, how many parts would there be now? We would have 4 out of 8 parts. What we want students to see is that 1/2 can have very different names. And if our drawings were more exact than my scribbles here, we would have exactly the same amount, but they would be cut into different size pieces. So therefore, 1/2 equals 2/4, which equals 3/6, which equals 4/8. They're different names for the same amount. When we begin to work with operations in fractions with students, we want to really focus on the question, what does the problem mean? And we want them to draw pictures. We want them to see the math, to see what the problem is asking them to do. So for example, in this problem, we might start out with a shape and we would show 1/4. 1/4. Now what is the problem telling us? It's telling us we want to add another fourth. So here's our first 1/4. We're going to add another fourth, and what do we have? We have 2 out of 4 pieces. So 1/4 and 1/4 is 2/4. If we look at this problem, we would have 1/4, but this time we're adding pieces that are different size. So students would have to be able to picture what that would look like. What if instead of fourths, this picture were divided into eighths? Now we have 8 pieces. The problem is asking us to add 3/8 to the 1/4 that we already shaded in. There's 1/8, there's 2/8, and there's 3/8. Now we have 1/4 plus 3/8. And the picture is really our answer. If students want to name this answer, they can look at the pieces and say, are the pieces all the same size? If they are, then we can name them. So we have 1, 2, 3, 4, 5 pieces out of 8. So 1/4 plus 3/8 is 5/8. No common denominators, just a picture, so students can see how it works. Subtracting in fractions can be confusing for students because they see 2 amounts and sometimes they want to picture 2 different things, when in reality we need to think about what does the problem mean. So in this first problem, it means we have 4/5, 1, 2, 3, 4 out of 5 pieces, and we want to take 3 of those fifths away from what we started with. It's not a separate amount. It's already part of what we have. Just like in regular subtraction with whole numbers, we're breaking something into its pieces. So we have 4/5 and we're going to take away 3. If we take away this one, and this one, and this one, we're left with one piece that is shaded out of 5 that it would take to make a whole. So our answer is 1/5. This is very much the same as saying if I had 4 apples and I take 3 apples away, I'm left with 1 apple. The 5th is just the name of the piece, the name of the size. We can also have students subtract even if the names of the pieces are different. So for example, if I have 5/8, 1, 2, 3, 4, 5, and I take away from my 5/8 1/4, I need to be able to picture what 1/4 of my whole would look like. So if I look at my whole and I just look at the lines that would help me to define 1/4, there's a fourth, there's a fourth, there's a fourth, and there's a fourth. Now what is the problem asking me to do? It's asking me to take 1/4 away from my 5/8, which is what I've shaded. So I will decide to take away this piece. I could take away a different one if I wanted to, but this is the one that I'm going to get rid of. So what am I left with? I'm left with 1, 2, 3 pieces that are shaded out of 8 pieces total. Because to find the total pieces, I have to make sure that my pieces are all the same size. 1, 2, 3, 4, 5, 6, 7, 8. There were 8 pieces in the whole. So 5/8 take away 1/4 is 3/8. Students can see it from the picture. Multiplication in fractions can also be difficult for students. We want to make sure that we teach this with both whole objects and also fractions. So for example, in this first problem, we have 3 whole of something. So let's just say that we have 3 whole circles. 3 circles. Now what is the problem asking us? It's asking us to take 1/4 of our 3 circles, to take 1/4 times our 3 circles. The easiest way to do this might be to break each of our circles into 4 parts and then take one of the 4 parts from each one. So if I take that piece and that piece and that piece, I now have taken 1/4 of my 3 circles. I've taken my 3 circles 1/4 times. So what do I have? I have 1, 2, 3 pieces out of 4 that it would take to make a whole circle. So if I take 1/4 of 3 circles, or if I take my 3 circles 1/4 times, I have 3/4. I could also take 2/3 of a shape. This is what I'm going to start with, 2/3. And what is the problem asking of me? It's asking me to take my 2/3 piece, that's right here, 1/2 times, or to take 1/2 of it. So if students look at this piece, that's my 2/3, and I want half of that piece. I want to take it 1/2 times. They could see that a half would be one of those 2 pieces. So my answer would be 1 piece out of 3 pieces that it would take to make the whole. So 1/2 of 2/3 is 1/3. And that's really quite logical when students look at the picture. What about this problem? What if I start with 3/4 and I want to take my 3/4 3/8 times? 3/8 of 3/4. That's actually pretty complicated. How can I take 3/8 of a piece that shows 3/4? There's my 3/4. I need 3/8 of that piece, or I need to take it 3/8 times. That's complicated. The easiest way to do this might be to divide each of my pieces into 8. If I divide each of my pieces into 8, then I could take each of those pieces 3/8 times. So I would take 3 pieces out of the 8 of each one. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm taking 9 pieces out of the pieces that are in the whole. But if we look at my picture, we notice that our pieces are not all the same size. And we can't name a fraction unless our pieces are all the same size. So to make them all the same size, I would also have to do this. Now my pieces are alike, so now I can look at how many there are in the total, in the whole. And I would find that there are 32 pieces. So if I start with 3/4 and I take 3/8 of my 3/4, or I take it 3/8 times, my answer is 9/32. When we teach students to divide fractions, we must start again with that question. What does the problem mean? In this first problem, it means we have 6 whole shapes. 1, 2, 3, 4, 5, 6. We want to know how many pieces that are 2/3 size are in our 6 whole shapes. So if we divide each of our shapes into thirds, what we're trying to find out is how many 2/3 are in all of these. So if we look for 2/3, there's 1 2/3, 2, 3, 4, 5, 6. If we put this one and this one together, we get another 2/3, that's 7. If we put this one and this one together, we get another, that's 8. And if we put this one and this one together, that's another, so that's 9. So the question is, how many pieces this size can we get out of our 6 wholes? And the answer is 9. Students will want to sometimes try to add a denominator to that because they'll think, I'm working in fractions, it should have a denominator. But the truth is, the answer is just 9 pieces. That's how many we can get out of that shape. For the second problem, we're starting with 7/8. So we'll make eighths. We'll shade 7 of the 8 pieces. And now we have 7/8. What is the problem telling us? What is the problem asking us? What does the problem mean? How many 1/4 size pieces are in those 7/8? So if we go back and look at our drawing, a 1/4 size piece would be that big. So we have 1, 2, 3, 4 of those in our whole, right? But the question is asking us, how many of those size pieces are there in the part that's shaded? There's 1, there's 2, there's 3, and here is half of another one of the pieces that would be that size. So our answer is 3.5. Notice again that if students were asked to calculate this problem, it would be very confusing. But by looking at the picture, they can almost see the answer. It's right in front of them, so it makes sense to them. When students are working with fractions conceptually, they're working with real objects, they're working with drawings, they're drawing pictures. It's also important for them to connect fractions to real life. They have a lot of experience with fractions, so we need to make sure that we ask them, where do you see fractions? One of the things I like to do with my students is to give them a recipe and say, we're going to triple the recipe or double the recipe, or we're going to cut the recipe in half. So for example, if you look at this recipe, sometimes I will ask my students to cut this recipe in half. I'll say, we aren't going to need this many cookies. We're just going to have the recipe. That means we have to cut all of these amounts in half. For some students who really understand this, I might even add a piece to it. I might say, the only 2 utensils you have are a 1/8 cup and a 1/2 teaspoon. How are you going to make the cookies? How many will you need of each ingredient? It's challenging for students, it makes them think, and it's also real life. Fractions need to be real life.